All right, so for the first part of the video lesson, you can refer to the handout that I posted on Canvas, but the handout will have the Frayer model, blank Frayer model for you, and this is going to be optional, but I would recommend if you want to have a very good summary of the sequences of arithmetic, geometric, then start with the arithmetic and start copying this Frayer model in your notebook, starting with the sequence, and then the explicit equation, and then the graph, and then the recursive equation. And as you're copying down the notes, you're reviewing this concept again. So that's optional for you if you would like to do that. And same thing for geometric, start with the sequence, then the explicit equation, then the graph, then the recursive. And this will be your final review of those two sequences before we work on the final review packet. What I do want to remind you is that the n values, which we call the term numbers, they determine the position of the numbers in the sequence. So for example, 10 is a first term. 10 is a first term because n is equal to 1. 7's a second term because n is equal to 2. So that's what the n value indicates in sequences. Now again, if you're going to copy this, please pause the video, copy that in your notebook or the handout. But I am going to move on to the second page of the handout, which you can find. And now we're going to practice some problems regarding these sequences. So here are some different problems that I have prepared for you. So let's start with the first one, and I'm going to actually move down to the bottom. So I'm going to do part A and C in the video. But if you want to give it a try on your own by pausing the video and then just come back to check, that's totally fine. Okay, it's totally up to you. So then for part A, you're given an explicit equation. This is an explicit equation, and you have to find the first 5 terms of the sequence. And as you can see, this is an arithmetic sequence, right? Because it has a linear form. So then if you're finding the first 5 terms, you're starting with n is equal to 1, which will be t of 1. That's a notation for the first term. So you just plug in n for 1, which is going to be 3 over 2 minus 1. But 1 can be written as a fraction. Any whole number of 1, as long as the numerator and denominators are the same, they're all 1s, giant 1s. So I'm going to rewrite 1 here as 2 over 2. So 3 over 2 minus 2 over 2, the answer is going to be 1/2. You might not have to do that, but I just wanted to show you. Then t of 2, 3 over 2 times 2 minus 1, which becomes 3 minus 1, and the answer would be 2. So second term of the sequence is 2, and then the third term, and so on. Minus 1, so 9 over 2 minus 1. Same thing, I'm not even going to bother putting in the calculator. I'm going to just write it as 2 over 2, which gives me 7 over 2. Don't need to change to mixed number. Same thing with the 4. Okay, and you're just going to keep going with that. Now, as for the bottom part, part C, I'm going to show you part C because B and D are quite similar. Part C, now you're given a sequence and you have to write both the explicit and the recursive. Let's always first find the pattern. So in this case, it seems like it's multiplying by -1. And you can check 4 times -1 is positive 4. 4 times -1 is -4. It's alternating. So it's multiplying by -1 each time. And multiplier can be negative. And I'm also going to find the 0th term by going backwards. If -4 is the first term, my 0th term will probably be positive 4. And now I'm going to start by writing the explicit equation first, which in this case, okay, you start with the 0th term, which is going to be positive 4. That's my 0th term. And then the multiplier is -1 raised to power of n. Done. Moving on to recursive. You always want to start with t of n plus 1 is equal to t of n. And it's multiplying by -1 each time, so times -1. I'm going to put parentheses around it just so that I know it's a negative number, not subtraction. And then the first term, which is this one. That's the first term, right? The first number in the sequence listed. And that's it. I will have the answers to all of these available for you so you can check at the end of this video, which will be very soon, but I do want you guys to work on it on your own and show all your work. You do not need to submit it, but this is the final review of the recursive explicit of sequences before we go into the final, okay?